Good day, folks. Welcome to our Learn Live session today on Azure ML Fundamentals. My name is Mir Alam. I'm a principal customer engineer in our Fast Tech for Azure team, helping our customer implementing solutions using Azure AI and data services. With me, I have my colleague, Marco. Marco, would you like to introduce yourself?
Sure, thanks, Mir. Hey, everyone. Welcome to our Azure ML Fundamentals session. My name is Marco Cardoso. I'm a data and AI engineer in the FTA team, and I'm really excited to be here. Also, make sure to say hi to Niraj. Niraj is going to be somewhere in this general direction, I believe. And here's our moderator for the session. He's going to be bringing the questions to us.
Thank you, Marco. And for the folks, we have a great collection created for you. If you'd like to follow along with us as we are discussing on Azure ML Fundamentals, please feel free to do so. We have the link in the slide, and I'm sure Neeraj is going to share the link as well in the chat session. We have a great session discussion today on Azure ML Fundamentals. We're hoping that if you're new to Azure ML service, bringing your ML solutions to the service, these sessions will be very helpful for you. We'll just walk you through the Azure ML service, the Azure ML Studio, and how you can get started with the Azure ML Studio to implement your solutions leveraging the UI as well as the SDK way of implementing your models. So session goal is at the end of the session, we're hoping that it'll make your life easy to just get started with the solution in Azure ML, leveraging the tools that we have available. So Marco, why don't we just play a little role today? Obviously, as we are playing the role for the audience, please feel free to just look at the contents we have. So Marco, I'm a new to Azure ML. I do have a model that I created. Now I'd like to bring this model that I created in on-prem using the open source tools, but I would like to bring it to Azure ML. Where do I start?
That is a great question. It's a question that a lot of customers come to us when looking for Azure machine learning, right? So they have their own implementations. They're using Python, Pandas, TensorFlow, a lot of the open source libraries that are available out there. And they want to bring this to the cloud, either to scale out or to get access to more tools. So Todd, if you can switch over to my screen, I want to show you how you can get started. So this is the Azure portal. Many of you in the chat will know what this is. Maybe you may have worked with this before. It's at portal.azure.com. And as soon as you set up your subscription, you're good to go to start working with Azure services. So the first thing I would do as a data scientist or data engineer who wants to bring ML models that it builds on premises to the cloud, I would go to the Azure portal, and Azure Machine Learning is always up here on my favorite services. But if this is not the case for you, you can just go ahead and search for machine learning. And it's certainly going to be up here. We're looking for this service right here. So I already have a couple of services created, but I wanted to show you how you can get started yourself. I'm going to go ahead and click Create and add a new workspace. The workspace is where all of the magic happens, where our code lives, where we can bring our data, where we can deploy our models, and everything else. So to create your Azure Machine Learning workspace, as always, you're going to have to select a subscription to deploy it in, and a resource group. You can either use an existing one or create a new one. I'm just going to pick one of my existing groups. And you're going to give it a name, such as ML workspace FG Live. Right? And you can see we also need to pick a region, and a few other services are going to appear below this. What are these services? So these are the services that give support to our machine learning workspace. So apart from the algorithms themselves, we need somewhere to store our data and our source code. We need somewhere to store our secrets, and that's our key vault. So anything that we want to keep away from the storage account or away from our source code itself goes into the key vault, like connection strings, passwords, anything that might be considered sensitive. We have Application Insights, which is a service in Azure that helps you understand how your applications are behaving. So once we deploy these models, we want to understand how many requests they're supporting, if they're performing well, if they're consuming too much resources. That sort of question will be answered by Application Insights. And finally, we have Container Registry, which many of you may be familiar with, which is where we store our Docker images. So any environments that we build go in here. Go ahead, Mir.
I was going to ask, like, do I really have to have the key vault newly created as part of a key vault and already in the service like container registry as part of the workspace provisioning, or is it possible that I have an existing container registry or the key vault or application insight, I can leverage those?
Right. So usually you'll create those separately just to keep those resources separate, but you can absolutely go ahead and choose an existing service. So I have a few here that I could just bind to this service, and I wouldn't need to create them on the fly. One thing that I would recommend all of the new users to do, though, is you can see not all services are required. So Container Registry, for example, isn't required from the get-go. But I do recommend you create all of these services because they will give you a better understanding of everything that the platform has to offer, so you can enable them and disable them as needed. Did I answer your question here?
It does. Thank you very much. Let's go forward.
All right. So I'm just going to give this a name. I'm not actually going to go through with the creation, so I'll just give ACR123. It's going to validate my name and hit save. And I can show you the other configurations that we have available for our Azure Machine Learning Workspace. So once we configure these dependent services, we can move on to networking. So right now for our demo, I'm going to keep this workspace accessible from public networks. So that means anyone who has access to our subscription will be able to access this without a VPN or without being on an on-premise network. But typically on a production scenario, you're going to want to disable public access as much as possible. So if you flip this option, you're going to have the option to create private endpoints, which will allow you to connect more securely to your workspace. You can see there's a few more requirements when it comes to private workspaces, but we're not going to worry about those right now. Just going to leave it enabled. For advanced features, we have a few features that are related to security specifically, both security and identity, in fact. So you have the option to change how your service connects to its dependent services. So how Azure ML connects to storage account or to Key Vault and so on. So these are also about that, how it's going to access the storage account. We can handle data encryption by including your customer managed keys. And you can enable your workspace to stop collecting metrics in case it is a high business impact workspace. So this is going to limit our options when it comes to logging and debugging, but it's also going to provide a performance boost that may be necessary in those critical use case scenarios. Finally, as always, with all Azure services, you're going to go in Azure tags. We recommend you always tag your services so you know what they're for, who pays for them, who commissioned them, and so on. And you can go ahead and review and create your service. You can have a very handy summary of what you're creating. This action takes a couple of minutes. It's quite fast, but I won't do it right here for the sake of time. I've already created a service. And once it's up and running, you'll see it under this list. So I have my ML workspace right here, and I can start working with it. One thing that you'll notice once you create your Azure ML workspace is that there's not a lot of features here. I can't see any scripting, any Python in this screen. This is mostly how you manage your service. One thing that I would point out on this view of the service is the access control. So under access control, this is where you give your additional users access to the workspace. So say, for example, I wanted Mir to have access to this newly created workspace. What I would do is go into role assignments. You can see who has access to my service already, and I could add a new role assignment. Let's say I want Mir to be a contributor, and I can go ahead and add him. So under members, I'll choose user group or service principal. I'll look for Mir in this field, and there he is. I can add him. And once I assign this new role to Mir, he'll be able to view this workspace and work on it. So contributor access will allow him to create models, to work with scripts, and so on. Just gonna go ahead and assign.
Okay. How about if I want to control the access? Like, for example, contributor may be a little bit broader permission that than I envision, because my team members are data scientists. I manage the service, but at the same time, my team members won't manage the service, so to speak, but they will just come as a data scientist, will do their data scientist activities within the service. How do I go about controlling those permissions? Is there any recommendations that you would want us to share?
Absolutely, and that's a great point. Contributor access is usually your write all type of permission. And we usually have different types of roles. You have your data scientists, you have folks on your team who are going to be responsible for spinning up compute, adding virtual machines. You're going to have folks responsible for production models that are responding to requests. So you usually want these roles to be separate. So under our existing roles for Azure ML, if I go to add a new one, you're going to see a few different roles. This list is quite extensive, in fact, where you can get to choose the type of role that you're going to need for each person on your team. So the most common roles that we have here are the data scientists themselves. So these are folks who can write scripts, can train their models, can view some data, run analytics on top of data to understand what they need to do, and so on. Now, the compute operator, on the other hand, is the guy who can go in and spin up additional virtual machines, scale out clusters, provide this infrastructure that data scientists are going to need. So you can mix and match these roles to better adjust to your use case. Did I answer your question here?
It does. Thank you very much. And if I need to customize it, does this role assignment allow me to customize it the way I want to?
Absolutely. So you can see we already have a few custom roles in here, as this side column will show you. And these roles can be configured with as many or as few permissions as you want. So you can have a specific role that can do, can spin up additional VMs but not delete them. You can go ahead and create your custom roles for that.
Cool. Fantastic. Thanks for sharing. Let's
Sure.
move along.
All right. So as I mentioned, there's not much to do on the Azure portal now that we've created the service and established the access. Most of your work is actually going to happen in the Azure Machine Learning Studio. Now, the studio isn't the only way to work with Azure Machine Learning. As Mir talked about, there's the SDKs, we have the CLIs, which are programmatic ways of accessing the service as well. But for this session, we're going to be focusing on the studio, which is a guided user interface experience. So I'm going to go ahead and open my studio for this workspace. And this is our landing screen. So right here off the top of the interface, this is what we get. We get a summary of the functionalities. Right here, we're going to go through each of these. Recent resources, recent jobs that have been executed, an overview of your compute models and data. But you're usually going to be focused on this side menu right here. So this summarizes all the functionality that we have in the Azure ML Studio. They're divided into three sections. We have the authoring section, which is where all the modeling happens, scripting, Python code happens all on the authoring section. We have assets, which define our data, jobs, any reusable components that we've created, data and ML pipelines, environments, which are our Docker images and Conda environments, models and endpoints. And finally, the manage hub here describes the infrastructure that gives support to this service. So this is going to cover the VMs that we spin up, the clusters of compute that we create to run our jobs, any Kubernetes clusters or other types of compute that we assign to this workspace. It all goes on the Manage Hub. So this is where I'm going to get started. As Mir put it, if we want to bring our ML workloads to the cloud, our first stop would be to spin up compute. We need compute power to run our Python scripts or R scripts, or however we're running these models. So I already have one created, but you'll see that compute is divided into these 4 groups. And the reason for that is that different types of computes do different types of tasks. So compute instances are your basic type of compute. They're pretty much mapped to VMs. So these are virtual machines assigned to each user, and they allow us to run, Python notebooks, and even some light machine learning jobs. When you go to create a new instance, this is what you're going to see. You're going to be giving your compute a name. As I mentioned, this VM is assigned to a single user, so only one user gets to access it. So typically, you'll have one of these for each data scientist, if not more. You can choose the type of virtual machine, whether we are doing CPU or GPU intensive tasks. By the way, the location is locked to the location of your workspace. So in this case, I'm using East US. That's why I can't change that. And you get to pick the size of your VM. So you have a pretty wide range of VMs that we can choose from. These are, of course, the recommended options, but we can always switch to all of the options in Azure. This list is quite long. I'm going to start with the recommended options. Usually the memory optimized is a pretty good fit for all use cases. So you can go ahead and choose that. If you have no idea where to start, this is a pretty good place. And under advanced settings, you get to further customize that machine. So you get to add a shutdown schedule to make sure you're not expending resources when that machine is not under use. You can establish SSH as access by adding a key in here. You can add it to a virtual network so that access will be private instead of through the public internet. You can assign it to another user. And so this speaks to the use case we were talking about, where a user responsible for compute would create these computes for different users. Say if I wanted to create one for Mir, I could just go ahead and add it here. You can set up a script on startup, a managed identity, which will let you authorize to other services. You can add applications if you want Jupyter Notebooks or RStudio to be installed on this VM. You get to customize quite a bit. So once you're ready and you're happy with your configuration, you can go ahead and create that. And that's going to spin up a VM on Azure. That's going to be made available for Mir, who is a data scientist in this scenario, to use on his machine learning tasks. Are there any questions so far?
I do have one question. It's exciting to see how easy it is to get started going into Azure ML Studio. But what is the difference between normal like Azure VM and the compute instance that you created? Why would I not just be able to just create a VM and then just bring it up here for my data science job?
That's a good point. And you can actually do that. So if you look up at this tab here, attached computes, you can actually map your existing VMs, and there's an option here for that, to your Machine Learning Studio, and there's nothing wrong with that. You can use your existing compute to perform your machine learning tasks. There is some configuration that's needed for Azure Machine Learning to be able to access that VM, but it's certainly possible. The advantage of using compute instances instead is that Azure Machine Learning gets to manage these VMs for you. So it's going to take care of installing the software, making sure they're all running at the appropriate schedules. It'll overall give you an easier time when configuring these VMs. But of course, if you need to go all the way to configure these VMs, they have very specific requirements. You're free to create your own VMs and configure them on your own.
Okay, fantastic. How about the data science components? Meaning, if I compare this VM with the data science VM that we used to have available, are these the same? I mean, do I have to after the VM gets provisioned, do I have to configure the runtime for the data science kind of activities? Like, I have to install the libraries for different data science related Python libraries if I want to work with that. Do I have to do that kind of thing, or is it like going to build those for me, almost like creating a data science VM for me? How would that be possible?
You're absolutely right. So these VMs already come with a range of applications that are commonly used by data scientists. So you can see it already has JupyterLab, VS Code. It has a way to access it through a terminal. You have a bunch of different applications, and not only applications, but also the most common Python packages and dependencies that we see in data science projects are already there. So if you start writing a notebook and import pandas, import NumPy, they're already going to be there for you. You don't need to spend any more time configuring these VMs.
Oh, cool, fantastic. Then that means that I really don't need a laptop to set up and configure all those Python libraries and all those Python installations. I can just spin off the computer instance, and off I go and start my machine learning activities on it.
Absolutely. Of course, there are going to be use cases where you need to configure these further, and we're going to talk a little bit about them during this session. But for most use cases, you're already good to go.
Cool. Let us walk through the journey.
All right. So I'm not going to wait for this VM to create, even because this is assigned to Mir and I won't be able to access it myself. Instead, I'll be using the one that's already up and running, has a reasonable size and everything I need to get started. So now I'm assuming, Mir, because you have a model created already, that you have some code you want to bring to the cloud. Is that correct?
Correct. So that's
Right.
the goal. I mean, of course, I would be very interested in what are the other. You showed me the authoring experience. I guess I want to be more interested on. Let's just say that I have team members who are not data scientists but ML engineers, but would like to just explore out, figure out, okay, how easy it is to get started with the authoring experience in Azure ML Studio. I'd be very interested to get an insight on that.
That is great. And we have a lot of different features here to help you with the authoring process while still giving support to existing data scientists. So folks who already know how to code, Python experts such as yourself, are going to feel right at home with Azure ML.
Cool.
So the next step, as you may have guessed, is to start with authoring. Now that we have our compute power up and running, we're going to start with the actual modeling itself. So as I mentioned, if you're a Python expert, you're going to want to skip right over to notebooks. And this is where you can get started with code right away. So say, for example, you have a notebook already where you're developing your models. You can add it right here. You can either upload it from your local machine or create it right on the interface. Let's say I'll call this modeling notebook. Go ahead and create that. By the way, you don't only get to create notebooks, you can create scripts and different types of files. And you're free to hack away at this interface right here.
Cool.
If I go and write print hello world, you can see that it's already bound to my existing compute instance. This is the only one I have access to. And if I try to run this, it's already up and running and it can get started with Python.
Oh, cool.
To speak to a previous point, if I go ahead and import pandas, you can see that it's already there and ready to be used.
Sounds great. I see like Python 3.10 SDK V2. What's up with that? I mean, what is that referring to on the right side?
Oh, right, over here, right?
Yeah.
Cool. Azure ML comes in with a lot of different environments that you can experiment with. So not everyone is going to be using Python 3.10, for example. You may have folks still using Python 2.7 or others. So you have here some versions handy. So if you want to use R instead, or if you want to use Python 3.8 with different libraries installed, you can go ahead and switch over to these environments. And these have different dependencies installed. So SDK V2, what SDK are we talking about? So as we mentioned, the studio is just one way of interacting with the APIs in Azure ML, and the SDK is a big way to do that. The SDK V2 is our latest version to interact with the Azure ML API. So if we want to target different types of compute or load data from it, load specific scripts, we would do that using the SDK. And if you're interested in seeing how that SDK works, we have a handy feature here called snippets, where you can get started right away. And these snippets show you how to get started. So the first thing you would do is connect to your workspace. You can see, for example, how to get a data set or get a compute. And you can copy these snippets right into your notebook as you go.
Fantastic. That's going to be very handy as you get started. Thanks for
Absolutely.
sharing. Yeah.
So your experience and the experience of data scientists is certainly going to be very valuable here. They can pretty much copy over their existing scripts, and most of them are going to work. But we encourage you to explore the SDKs as they make our lives easier as data scientists.
Cool. Sounds good.
Cool. But I mentioned this is not the only tool for authoring. So we have actually a few different options here. We have automated ML, which is going to do all of the data processing, modeling, and evaluation for us in an automated way, and even compare different types of models. And we have the designer, which is a fully UI tool where we can design these processes around data modeling. So before I jump into those, I actually need to bring my data. I still don't have any data here in the Azure ML Studio, so let's get started with that. So before we start modeling, I'm going to jump over to the Data tab. And you'll see I already have an asset here as a backup, but I'm going to show you how to add a new data asset. But before I do, I wanted to jump over to data stores. So Azure ML allows you to bind different types of data sources to your workspace for easy access. So usually with Python, you're going to have to worry about connection strings. Maybe you're connecting to a SQL data store. Maybe you're connecting to a blob storage. And it's up to you to actually make that connection securely and in a way that's repeatable across different ML experiments. Right here in Azure ML, you get to do this in a unified way for different types of data sources. So you can see I already have some blob storage and file share types of data store connected. These are default, by the way. They'll already be on your workspace when you create it. But you can create different data stores for different types of data. These are the ones that are supported right now on the UI experience. So apart from blob storage and file share, you can connect your data lake accounts, Azure SQL, PostgreSQL, and MySQL. And all of those are going to look the same from the data science perspective. So we don't have to worry about what the type of data is. It's just going to be connected to our workspace. I'm not going to create one right now. I'm just going to use the default, which is a blob storage. And if you're not familiar with it, it's based on our storage account that was created automatically. You can see its name right here. And I'm going to go ahead and create a data asset on it. So you're going to want to hit create. I'll give it a name. This is a data set that I use for most of my demos, and I encourage you to do that if you're just getting started. It's called the seeds data set. And you can find it either on Kaggle, you'll find it on GitHub. It's really everywhere. It's a very simple data set that can be used for classification and regression problems when you're getting started with machine learning. It's a really easy data set to play around with. So you can't really test advanced types of algorithms, but it's a great idea to get started. You could give it a description, and you're going to have to choose a data type. So these are the types available right now, and there's a handy description of what each of them should be used for here over on the right. And you can see that they're split by V2 and V1 APIs. So we've talked about this. V2 APIs are a new way to go, and they have all the newest features in Azure ML, so we encourage you to use it as much as possible. However, if you are just getting started and exploring the UI tools, you may want to use V1 APIs. For their compatibility, they in fact will get mapped to V2 resources as well. So if you create it with tabular, you're just going to see that data asset everywhere. And there's a description of that process right here. So I'm just going to go ahead and hit next. You can see we have a couple of different options to add this data. You can add it from Azure Storage, from web files. There's even some open data sets from Azure that you can use. In this case, I'm just going to add one from my local files. I'll choose a data store that's already configured for me. So in this case, I'll use Workspace Blob Store. And you can see it's going to give me the option to upload my own file to the cloud. This will make the file go to my storage account and create a link on my Azure ML Studio so that it knows where to find that data. So no matter where it is, it's going to know where to find it. I'm going to go ahead and upload it. I have this file right here in my local system, and it's called seeds.csv. It's a CSV file. Actually very simple. I'll give you a quick overview of what's in it. After uploading your data, you're going to have the option to tune how Azure ML understands it. In this case, you can see it already gives me a pretty good preview of what the data looks like. So we have area, parameter, compactness, kernel length. These are all characteristics of wheat seeds. And in the end here, we have a type, which is either 1, 2, or 3. And that defines the type of wheat seed. So this is typically used in a classification type of problem, where based on all of these features in our data, we want to guess what type of wheat seed this is. So with that, I'm just going to go ahead and add that data. You can toggle all of the columns or change their types if necessary. In this case, everything looks good. I'm going to hit next. You can quickly review everything that you're creating and hit create. Once you've created your data, you can either explore it, so you'll be able to see that preview we saw before to understand what this data looks like. You can generate a profile. It's not generated yet, so it's already generated. That was fast. So you can get a feel of how your data is distributed according to different features. You can see there's a lot of statistical analysis tools which really speed up the EDA process. So if we're looking to understand this data, yeah, go ahead, Mir.
Yeah, I was gonna say like that's super cool. I mean, this is what the initial data exploration look like if I start doing it in the Python, and it's doing it already for me.
Absolutely. So you already get an idea that your data is perfectly balanced. So this is great for us. You can see there's some features which are bimodal, so they have some separation within them. It's really great information about our data that we get out of the box with Azure ML. So now that I have my data, I can use it to start modeling. So let's get that model up in Azure ML. I'm not going to start with notebooks. We have a dedicated session on the developer experience where we cover everything there is to know about the notebooks and the developer experience in Azure ML. If it's not up, it'll be there very soon. And I encourage you to look for that. For this session, I'm going to focus on the UI-based tools, so AutoML and Designer. So say you want to get started modeling very quickly. You want to use all of the power of Azure to get you started. you can go ahead and create an automated ML job. And what automated ML does is it's going to take your data, and based on the features on it, it's going to do all of the data processing for you. It's going to choose the best model. It's going to evaluate them. And it'll do everything at a very small number of clicks. So we'll start by choosing the type of the data that we're going to use. I can choose my seeds data set.
Yeah, does this feature automated ML help me with the featureization aspects?
Absolutely, it will do featureization for you, and it will even tell you what it did at the end.
Okay, cool.
And I'll tell you, as a data scientist myself, I struggle to beat this guy. This is a very good methodology. You know, it's applying all of the best practices in data modeling, and it's really tough to beat. I'll tell you that.
Cool, fantastic.
All right. So when configuring the job, it's going to ask us to create an experiment. So that's a grouping of ML-related tasks. I'm just going to create a new one and call it seeds experiment.
What's up with the experiment?
So experiments are this concept where we group different ML jobs under a single name. It actually comes from open source libraries that Azure ML is built on. So this is part of how usually we deal with this type of ML workloads, even outside of Azure.
Okay, cool.
So I'm going to create a new experiment. Again, this is just a logical grouping of these tasks. I'm going to pick a target column, which is what I actually want to predict. In this case, this is my type column, so I want to predict what type of wheat I'm dealing with. And I'm going to choose a compute type. In this case, I can use compute instance or compute cluster. Now, this is where we start to see the differences between different compute types. You can see you get two types here, but you can't use Kubernetes and you can't use attached types of computes. This is where you're going to see the differences between these computes. In this case, I'm just going to go ahead and use my compute instance and hit next. Next up, I'm going to tell it what I needed to do. In this case, we're talking about a classification problem. I know that because my output is a discrete column, so it's either 1, 2, or 3, and nothing in between. I'm not going to enable deep learning, but that's an option you can use to add different types of models to your analysis, though it will cost a little bit more, even in time and compute resources. So I'm just going to leave it at classification. Just for you guys to know, we have other types of problems here. We have regression, which is when you're trying to predict continuous numeric values, time series forecasting to predict based on time, natural language processing, and computer vision. This is all built out for you. You can see it'll even try to predict what it is you're trying to do. So as you're creating the job, it'll analyze the data and say, okay, this is what I think you need, and you can tune it further if needed. Other configurations that you can add are in these two icons. So we can add additional configurations. We can choose the primary metric by which it's going to choose the best model. The data scientists out there are going to know what each of these mean. But these, in short, are different measures of how good a model, a classification model behaves when scored against. So in this case, I'm going to use area under the curve. I'm going to leave it to explain the best model it finds, and I'm going to tell it to use all supported models. And by the way, this is the list of models supported by AutoML. So what's going to happen in the end is Azure ML is going to start analyzing the data first, understanding which models are probably going to be the best, and come up with a strategy of an order in which to try these models. So it's going to train an SVM, it's going to train k nearest neighbors, a decision tree, and so on. And it's going to evaluate them as it trains each one. And not just one model for each algorithm, it's actually going to do hyperparameter optimization for us. So it's going to go ahead and train multiple models of each and choose the best one each time.
That's even better. I didn't realize it does the hyperparameter tuning for me in the process.
Absolutely. So this is very, very powerful, and it even accepts your input as a data scientist. So if you, for example, already know for this problem, okay, I don't need all of these models. A decision tree is probably enough. So instead of just using everything, you can just choose the models that you want to test out. Say I want to
Okay.
test decision trees, random forest, and logistic regression. Next, you can add some additional classification settings. This is especially important when we talk about responsible AI. So if you're going to do a credit score modeling, something where the output is either positive or negative, you may want to add this to generate additional statistics of how fair your model is in a way. This is not the case for Wheat, thankfully. An exit criterion, which is going to tell your automated ML job when to stop. In this case, you can choose either a time limit, which I'm going to choose half an hour, and a metric score threshold. So when it reaches a certain metric, it's going to stop generating new models. Again, we're talking about area under the curve. So it's a metric between 0 and 1. I'm going to give it 0.999. And you can configure concurrency. So by default, it's just going to train one model at a time, which will make the best use of the resources. But if you need this done faster and you have the compute available, you can go ahead and add more concurrent iterations. So going ahead to save that, we can also view featurization settings. So how your models are going to interpret each of the features. By default, everything is going to show up as automatic. So all features will be interpreted in the best way possible. But you can go ahead and tell it exactly what type of data is in each of these columns. So in this case, they're all numeric. I'm just going to leave all of them in auto. You can also impute the data, which means adding data with where there's missing information. You can impute with the mean, most frequent, median. I'm sure data scientists will be happy to see this this feature already here.
Absolutely, yeah.
So with that, there are additional configurations for computer vision, but those are not going to show up here. We can choose our validation type, which by default is going to be a cross-validation. So it's going to hold out some data from each fold and train multiple models to evaluate it. But you can also use Monte Carlo, train validation split, which is going to ask you to hold out some data for testing, or user validation data if you want to specify the test data yourself. In this case, I'm just going to leave it as auto, which will trigger cross-validation. With that, I'll go ahead and finish, and my job will be created in a second.
Cool. Sounds good. It sounds like pretty easy to get started with AutoML. Would you recommend this to the seasoned data scientists, or is it like a specific, like, okay, I need to get an idea about my data and what kind of model would be best fit for me? So I'm gonna get started with AutoML, get the best possible insights about the type of model that I need to leverage, and then I'm gonna go back and probably I have some code that I can take from the generation of the model and leverage it and go do my own development for a bigger project. Is that how would you characterize this, or is it like, for the production type of model that I need to create, I can start with AutoML?
So this is actually a great tool to get started. I like to say that if you can't beat what comes out of AutoML, you probably don't want to replace it. So as long as your data science efforts can't get a better model than this, I would certainly use it in production. This AutoML experiment will actually package the model very neatly in a way that's very easy to deploy. So you're free to do so.
Okay.
But as you said, this is a great first step. It usually brings great insights into what your data behaves when you're modeling against it, and the type of model that works best with it. So you usually want to do additional transformations feature engineering and other data science activities based on the outputs that you get from here.
Okay, cool, fantastic.
Great. So this is running. You can see it's already running featureization. I will not wait for this to execute. I actually have a job that I ran earlier based on pretty much the same parameters. And I wanted to show you what this looks like. You can see that the status is completed, and specifically it stopped executing because it reached our specified exit score of 0.99. A few cool things that come out of this AutoML job. Data guardrails is one. So as you're executing this experiment, a lot of insights of your data come forth. So validation split handling will verify if there's been a split to improve model performance. You'll detect if there's any class balancing problems. In this case, all outputs are balanced. We'll check if there are missing feature values or any high cardinality features, so any features that appear very uncommonly.
Mm-hmm.
There are more checks that happen in the background that will be specified here. If there's any issue with your data detected during modeling, this screen right here will tell you what's going on.
Oh, cool, fantastic. This definitely will be very helpful in the exploration.
Absolutely. So if there are any issues here, you can kickstart your data science journey a lot faster.
Cool.
All right. Before I go into models, which is going to show the models that actually got generated as part of this output, I wanted to show you the child jobs, which shows everything that went into creating this model. So you can see a lot of the jobs are canceled because as soon as it got what it needed, it stopped executing. But as part of this process, you got a feature engineering job, data preparation job, and your training jobs. And those are tagged right here. There's even an explanation module here that's going to tell you exactly how well your model is performing. So for this use case, thankfully, the first model already exceeded our specified threshold. But of course, if our threshold had been more aggressive, we would get more models on this list. You can see two names in here. The first one is our featureization strategy, in this case, max absolute scalar, which is going to scale our data between in a specific interval, and the actual model itself. And if we open these up, we get even more information about this model. A pretty good overview of how this model is behaving is right here on metrics.
Wait. Can you go back to the explanation view for a moment?
The explanation or the overview?
Explanation view, preview.
Okay.
Yeah. Okay. Oh, cool. I also see that there is a way to do like a data. I mean, not the data code explore, right? I mean, you can just say that view generated code and explore it out and see what are the different codes that being generated for the model itself. Is that the idea?
Yeah, that's the idea. So any model that gets generated, we'll see, and let me scroll over to the side here. You can see that it generates, well, not code, but actually outputs. You can see that it generates a few files, including the model itself. So these are the files. You can see there's a pickle file with all the model's code that you can run later. And also these outputs include, logs, explanations, metrics, anything that you may need to further explore these models.
And if I drop down on the view generated code, what does if you just click on the view generated code, is that what does that give me?
View generated code.
Okay.
Oh, that's.
I'm hoping that it actually generate the code for me, that I can look at it directly.
Exactly.
Yeah,
So
like
that's
a
the idea.
notebook or
It's
something.
not. Yes. So it's not going to be available for every model. I don't think it is for this one specifically.
Makes sense. Yeah.
Let me just go back to my experiment. and my model. So these are features that are going to be there for every type of model, but they won't be implemented for all of them.
Okay.
So some models may have the ability to generate the code, which you can directly copy and paste over to your notebooks.
Okay. And the explain model, what does that give me?
So the explanations, let me see. I didn't want to generate a new explanation, but the explanations view shows you, it tries to explain why it made a decision, right? So this isn't too much of an issue when we're talking about wheat seeds, right? Because it's not a problem if a wheat seed is type 1 or type 2. But this is a big problem when we talk about credit, for example. If we want to tell a person, hey, you do not qualify for credits, the first question that they're going to ask is why. So this gives us a view of why it made the decisions that it made. So you can see, for example, aggregate feature importance will show us exactly what features in our data set are the most important in determining the type of the seed. As you can see, area is the winner here.
Right, got it.
It doesn't really mean area is the only feature you need to determine the type of seed, but it's a really important feature. And this really becomes an issue when imagine you run one of these on a credit evaluation model and you get the first one here as gender. Can you imagine? When we shouldn't even be using that as a predictor.
No, it's
so it's important to understand if these models are fair or not.
Yeah, cool. Yeah, so that's definitely a very insightful and handy tool to get that explanation right there when the model gets generated. I can see and it will be very clear to me what feature actually was contributing to the model performance and why it made the decision based on that feature. Correct?
Absolutely.
Cool.
All right.
Very forward. Sorry, I'm just stopping you. I just had so many questions. I mean, me, data scientist, I want to have a tool that's very easy for me to jump into and get me essentially productive the next day. That's why I'm asking so many questions.
Absolutely. Please feel free to stop me at any time. By the way, I see a question from the audience. How do we have a report on the best performing models or a comparative view of these different models? So as we're running an experiment, and let me see if this one is already creating a few models. So this one, I added a more aggressive AUC requirement. So you can see it's already generated quite a few models and evaluated them. You can see we have maybe 10 or so models already, and they're rated from by the AUC, and currently this is the winner, right? But you may have different requirements on your solution that may tell you, okay, I could use logistic regression, but I think random forest is better for this use case. So you can just switch over. Also, a few of those models may be heavier or harder to explain than others, so that may also impact your decision. This is the view from within a specific job. If you want to compare different executions of that same job, we'll refer to the experiment view. And in here, once jobs are available and completed, this one is still running, you'll have the evolution of the accuracy of or whatever metric you defined. So going back to my backup experiment, we could add, oh, I didn't mean this one. Let's go back to my jobs, seeds experiments. All right, it's going to have data in a second. These two are the average precision by weighted metrics and the macro average. These are going to show the evolution of this metric over, not necessarily time, but over different iterations of the same model. Hope I answered your question, Viraj. Please let me know if there's any follow-ups.
Cool.
All right. With that, we've created our first model on Azure ML. So this is still running, but we already have a few models available that we can use already. Again, if you want to choose a different one, you can go ahead, but I'm just going to select the best one so far. And there's a couple of things you can do with these models. The first thing we might want to do is register it. So registering a model is pretty much saving a pointer to that so that we know where to find it when we need it again. So we'll save it in a specific location where Azure ML can refer to it or deploy it or use it in a specific task. So you can go ahead and register it. The default model type for most models generated by AutoML is going to be MLflow, and that has a ton of advantages. It's a unified model format that's accepted in different versions of Python. It allows different types of underlying technology. For example, if you have a scikit-learn model or you have a keras model, you can group them under an MLflow model type. And the files are going to look very similar. You pretty much every time you'll get a pickle file, an ML model file, which is going to describe how that model should be used. A few YAML files that contain additional information about the environment, and a requirements.txt in case we want to run this on a specific server. So registering this model will save all of these files in a specific location. I can give this a name. Let's say seeds model. I'm going to go ahead and hit next.
Is that what is called a model registry? Is that how it's named?
Exactly. So this is a feature in Azure ML. The model registry will keep track of all of our models, different versions of them, and as we deploy them, we get to see how they evolve over time. So after registering it, we'll find it under models. We already have a few here, but this is our newly created one, and this is how we would save a new model. Now, the last task we may want to do with these models is deploy them. We want to actually use them to make predictions, right?
Exactly.
Mir, can you tell me how you want to deploy this model? How do you see it being used in your use case?
So great point. So I would envision, okay, so more the deployment would mean, okay, so I have this model in certain place where I can simply access it via maybe some kind of URL, and I send my data, and it just send me the score. I mean, I can inference against that endpoint, and it would be great to have basically multiple options. I could use compute cluster. I could use maybe you showed me a case compute type. I can use the AKS compute type, or maybe I want to even deploy it to Databricks cluster, or for that matter, in the Synapse we have a Spark cluster, right? So I would love to have the flexibility of deploying to a place where I can access it via some kind of endpoint like a URL, and then it's easy for me to code against it. So I send the data, and then it responds back to me, and it is compatible with multiple type of applications like Power BI. If Power BI is an option for me to get the access to that URL endpoint, fantastic. That's what I'd love to see.
It's great that you brought that up, because you've just described our real-time endpoint deployment. So you can see for every model, you get the ability to deploy them. You can either use real-time deployment, which is, as you described, it gives you a URL where you can send your data, and it's going to respond with the actual inference of what's the output from your model. We also have batch endpoints, which are going to run this model against an entire file or database. This is more for batch types of use cases where we want to do predictions in bulk. And for specific services, we may also want to do web services, which is going to deploy either an app service or an Azure container instance that will do pretty much a similar job to what we have with real-time endpoints. So let's do that. Let's get started deploying our model. When you do a deployment of an MLflow model, as I mentioned, this is packaged just right for Azure ML, so it already knows how to do it, right? So it's going to tell you, hey, for the selected model, the scoring script and environment are auto-generated for you. You don't have to worry about them. This is because Azure ML already knows how to interpret MLflow models. It knows how to load them. It knows how much resources they require. it can automatically generate the entire Python application that serves this model without you needing to configure it at all. Of course, you get a few options with regards to scale. So you can choose the size of the virtual machine, even though it will have a suggestion for you. I could lower this, for example, even though it's going to tell me, hey, this may be too small.
That's fine for exploration, right?
It could be. I have had some issues when trying to defy the recommendations from the platform. So I would just initially follow them.
Okay, I see.
So you can choose an instance count. That would be your horizontal scaling. If you need more throughput, you probably want more instances. I'm just going to leave it at 1 for exploration. I'm going to let it create a new endpoint, which I will call seeds. And also give our deployment a name. The difference between an endpoint and a deployment is that you may have multiple deployments under the same endpoint and load balance between those deployments. So that's very useful for blue-green deployments. When you want to bring stuff from dev to prod, you're usually going to want to do this in a phased manner so that you do this in a careful way and make sure you're not breaking production unnecessarily.
Oh, cool. That's a good option. Before you click on deploy, I do have one question. If you scroll up a little bit, there are two keywords came to my attention, and I also see that audience probably has a related question. Scoring script and the environment; those are auto-generated. However, I mean, what's an environment and what is the scoring script? And if it is auto-generated, do I have the flexibility to generate it myself when I need a custom one?
Great question. So the scoring script tells Azure ML, when it's deploying a model such as this one, two things. It tells it how to load the model. So how do I get it from that pickle file into some sort of object that I can query? And it also tells it how to score. So once we have that object ready, what method do I call? How do I use this model when input data comes in? So for ML Flow, it already knows how to load them. It's going to use the ML Flow library to load the pickle file, and it knows exactly that it needs to call the predict method to actually use it. So that's already taken care of it for us. The environment, on the other hand, it talks about the dependencies, the Python dependencies that we need to install to make sure this model operates right. So a lot of you who have been using Pickle for a while know that if you don't have the exact same dependencies, you're very often going to run into problems. However, since we created this with automated ML, the dependencies are already defined for us, so we don't need to worry about it.
Right. Okay.
But in other custom models, you may need to tweak those, and there's the option to do so. I'm going to show this for a different model that we did.
Okay. So I should be able to create my own custom script if needed, and the environment for the type of development that I have, right? It may not be coming through the AutoML, but if it is a custom environment for me, then I have the option to create my own script and own environment.
Absolutely.
Cool.
All right. And here is the endpoint we were talking about. So this is how our model is going to be deployed. We're going to send post requests to this URL right here, send the data to be predicted on the request body, and the response is going to be the inference, so the type of wheat seed. With that, I'm going to go ahead and hit deploy. This is going to trigger a lot of different actions on the back end, so it's going to spin up a virtual machine just for this purpose. It's going to scale it to one instance. It's going to deploy this code, and it's going to start a server on it, which is going to be listening on the scoring API, which will be here in a second. As always, I already have one deployed so that we don't have to wait for this. I have it right here.
And that's the managed version of the deployment, right? So
Exactly.
when it's a managed, does that mean I have to manage it myself, or how does it work?
So a managed deployment, compute type managed, what does that mean? So as we talked about in the beginning of the demo, we can either have Azure ML manage the compute instances for us, and that's the compute instance and compute cluster types. Or we can provide those instances for it, such as VMs and clusters, and with that, we will be the managers of the infrastructure. So that's the difference. A managed compute is usually easier to work with, whereas a customer managed would be tougher, but more customizable type of option.
Nice. Like AKS could be a customer managed. Like I have my own AKS cluster. If I need to work with configuration, that I'll have to do it myself.
Absolutely.
Okay. Cool.
All right. So with that, we have our REST endpoint to call. If we make post requests to this, of course, you guys won't be able to access it because it does require authentication. But if I go to test it here, it already has that authentication built in. And it's going to let me run a few requests. Let's just wait for that to load. In the meantime, I'll get a sample file that we could use. Just grab that. All right. And I'm going to look for, actually, I won't grab it from here. Kind of let it load. While this loads, let me show you the consume tab as well. So the consume tab tells us exactly how to call this REST endpoint. You can see it generated a primary and secondary key for us to use. This goes as an authentication header so that we can access this endpoint. And we have a few options here as far as programming languages go to call this API. So there's an example in C#, where you're passing in the data. We have an example in Python. And we have an example in R. And you can see it already knows what the data should look like because that is part of the ML flow model package. So this is described within the model files. So this is loaded. We can see the format of the input. Right now, it has no data in it, so I won't be able to test it right away. It's probably going to give me an error because our data array here is empty. So say, for example, I wanted to add an item here, and you can see we have 1, 2, 3, 4, 5, 6, 7 different features. So of course, this is not going to make sense, but I'm going to give a 1 to every feature just for us to test this out. And this is going to be my data point 0. I'm going to go ahead and test. So you can see for my data point 0, the prediction is 1. So this is a prediction for a type of wheat seed given this input right here. This is nothing more than a REST API call.
I see. That's very easy to test it out right from within the portal itself.
Absolutely. And as part of the studio experience, you also get the deployment logs. So you can see everything that happens when spinning up the instance and all of the requests that are coming in. So you get this is a health probe that happens every couple of minutes or seconds. And our request is right here. It's a post request.
I see. Cool. Cool. And monitoring. So what does the monitoring tab show us?
So in the monitoring, this is going to show us a few more metrics about the model. This is going to be especially important when we go to production so that we know how many requests per minute are coming in, the request latency. This is going to tell us if there are any problems with our deployment.
Yeah, it's against the endpoint, right? Or is it the model performance also be showing up here?
This is just the endpoint. For the deployment logs, will be focused on the model deployment itself. So this actually monitors multiple deployments at the same time.
I see. Okay, cool.
Yeah, you can see right now we only have one deployment, but if we had multiple, they would just show up in different colors.
Cool.
All right, so with that, we went through the end-to-end process of setting up compute, bringing in our data to Azure ML. We explored different options here to develop our models, and we've deployed them using Azure ML. So this was the end-to-end flow. Before I pass it back to you and we talk about closing remarks, I just wanted to talk about a different option for authoring models, which is the designer. And folks who are already familiar with data science processes and want to start out building these types of solutions, but still in a low to no code type of way, may want to use the designer. And what the designer is just a way to structure these processes with a drag and drop type of interface. So we have a couple of examples here that we could test out, but you could just create a new one if you like. And this, I won't create one from scratch because we are quite short on time, but this is what it would look like. It lets you bring in your data, really drag and drop interface, different machine learning algorithms. So say, for example, I wanted a decision forest. Maybe I want to train a model, and I can just connect them as such. Really easy way to get started with data science. It really shows the concepts really well, so it's a great tool to start exploring Azure ML as well.
Okay, and there are two things came into my attention: component, and also on the way that the flow is, it almost looks like a workflow, and then I see a reference of pipeline under the assets. So is that what it is showing, that that relates to those components and the pipelines? And if you could reflect on those two items real quick for me.
Absolutely. So these components are pre-built, right? They're already here, and they're available to anyone who joins Azure ML today. If you want to build your own components, say you have a specific task to do something to do with feature extraction that's specific to your use case, you may want to create these functionality blocks yourself, and these are your components. So components can be created. I'm just going to discard this pipeline for now. But components can be created by uploading your code either through GitHub, Azure DevOps, or local files, so that you can have these chunks of reusable functionality within your pipelines. So it's going to ask you to just upload the code, and there's a specific interface that you need to follow to be able to use those.
And I could use my SDK too, right? I mean, would that be a possibility?
Absolutely. You could have a specific component that uses the SDK to either load data, process data, or write data.
Okay, cool. Sounds good. Fantastic.
All right. So just to reflect on a previous point that you mentioned, I did have, we also talked about pipelines, right? So every time you execute something from the designer, you're actually going to create a job, which will be of type pipeline. So I have one here that I executed a couple hours ago, where I'm training a multi-class decision forest on my seeds data set, just splitting the data, training a model, and scoring it. And once I submit this, and there's a submit button right here, this becomes a pipeline, which is the execution itself. So you can see we have logs for every single stage. So it's going to start from top to bottom. We'll create a multi-class decision forest, split the data, and you get logs for each step of the way. So every time it's going to tell you exactly what's going on. This is system exit 0, so it means everything went okay, but it'll tell you more information. And once we execute it, we get the same output that we did for automated ML. So this train model, for example, under its outputs, will have all the files needed to execute this model. This model is a different format. You can see it's not an ML flow type of model, but it still has all the files it needs. In this case, data.ilearner is the model itself. But since this is not ML flow, and it will require an environment and a scoring script, remember those two were worked out for us before. So it's providing us those scripts. You can see it's providing a scoring script that will need to upload it when deploying the model. You can see it pretty much just initializes the model and then has a run function to actually execute it. And as far as environment goes, it has a conda YAML file with all of its dependencies. So you would take this file, copy this over to environments. You can create a new one based on this conda environment. So you can give it a name, create it from a conda file. Let's do this really quickly. So seeds, environments. You can see it's going to start out with a default image. It's usually enough for most use cases, but you can customize it as needed. And you can add your conda file right here. So if I wanted to just, I didn't copy it.
For the sake of time, we can copy it. But does that mean that it actually is going to create a Docker image for the environment itself, and it's going to store on the custom environment, so that if I need to refer to that custom environment, it's going to basically leverage that one?
Exactly. So as I create an environment and add the conda file, this is going to trigger a Docker build. This will create an image and store it in our container registry, and you can actually see all of the build log right here. So folks familiar with Docker builds are going to recognize these. Everything is going to be installed, and that image is going to be saved in Azure Container Registry. Then when it's time to deploy the model, Azure ML knows to pull that image and run it in a container so that we can actually make predictions.
Cool. Fantastic. So we have lots of flexibility in terms of the scoring file, in terms of the custom environment that we create, etc.
Absolutely. All right. I see a question on our chat. So is it, if I don't have a predictor variable, what would it look like? So we talked about this in automated ML. When running an automated ML job, we had to pick a, just go through these real quickly, just set up a job. We have a target column, right? So if I don't have a target column, how would I do this? Target columns are the characteristic that defines supervised machine learning. So when you actually have a target to predict, there are other types of machine learning that do clustering, for example, which do not really have a predictor variable. There are different use cases for that. I'm pretty sure the developer experience goes into this a little bit, so stay tuned, and I'm sure this will be an interesting session for you.
I have I have a pointer on that data set predictor variable not present. I think when we look into different kinds of algorithms, like for example, you mentioned about clustering, supervised learning, but in our select the task and settings, we have an option to say, okay, so regression versus classification. It almost seems like regression type of cases where we probably do not have to use the predictive variable, but just go with the regression as a model and then explore out. Is that probably a reasonable way to think, right?
Absolutely, yeah.
Okay, cool.
All right, Mir, that was everything. I hope you can bring your ML model to the cloud now. I'll be sure to ask you about that later today.
Yeah.
That was everything I had to show. I hope this was instructive, that helps folks on the chat and our viewers to get started with Azure Machine Learning. And again, thank you so much for paying attention so far.
Absolutely. Thank you so much, Marco, for walking me through this, taking me through the journey, and in fact, like I feel very comfortable after the discussion that now I can just get my Azure ML service created, and bring my model and start playing with it. Thank you so much for walking me through the. And folks on the audience, again, this was an effort to have a conversational way of presenting you the experience of how easy it is to bring your model, start working with the models, and in an end-to-end journey fashion, leveraging our Azure ML service itself, Azure ML Studio, Azure ML Service, and the other tools that we have available. So I hope we will find it very beneficial. We had other sessions along with it. We tried to have 4 different sessions. Azure ML Fundamentals was the last one, but before that we had enterprise capabilities discussion. We have ML Ops discussion, as well as the ML developer experience discussion. I'm hoping you'll find all those very valuable, and it will just help you get productive with Azure ML service very quickly. And obviously, we are here to help you out. So thank you so much for staying with us and giving us your valuable time today in learning Azure ML fundamentals. We'll definitely bring more discussions, and feel free to let us know if you would like to have us present very targeted discussion on any of the Azure ML services. And thank you so much, everyone. That's all we had for today. And we have other sessions coming. Please feel free to sign in and listen to. Thank you, everyone.
Thanks, everyone.
Bye.